With example 2 of identifying proportional rates, we are told that one tree is 16 inches tall after 1 year, 32 after 2 years, and 60 inches after 3 years. And a second tree is 20 inches after 1 year, 40 inches after 2 years, and 60 inches after 3 years. And we're asked which situation represents a proportional relationship between tree height and number of years. And then we're asked to explain. So again, as with the previous problem, if it is a proportional rate, then the ratio of inputs to outputs or outputs to inputs will be constant. So we want to know, is height to time, inches to years, constant? So we're looking at 16 divided by 1 equals 16 inches in a year. 32 divided by 2 equals 16 inches in a year. But 60 inches to 3 years, that equals 20 inches in a year. So this is not proportional. This does not represent a linear relationship because in that third year it grew more than it did in the previous years. So now we'll look at tree B. I labeled them tree A and tree B, and I made a table of the information that was given. That does make it easier to organize and recognize. It's not necessary, but it is advised to go ahead and make the table. So we're looking at output to input, or inches to years, or height to time. And we'll look at those ratios again. The first one is 20 inches in the first year. That equals 20 inches in a year. It's 40 inches tall in the second year, which is again 20 inches per year. And then 60 inches in the third year, that equals 20 inches per year. So in this case, the second tree, or the one I labeled tree B, represents a proportional relationship. And for the reason, we could simply say that the tree grew a constant 20 inches per year. Or what would suffice as an explanation is the tree grew at a constant rate or the same amount each year, or you could say the ratio of height to time is a constant as well.